Okay, good morning everyone. It's really nice to meet you all finally, as Jeff mentioned. So my name is Veli-Pekka Ketonen. I'm a CTO with 7signal. So we have been communicating with many of you already in the past, and it's been really exciting. And today I will be sharing information about the 7signal technologies, showing as well examples on the optimization, which seems to be a really interesting topic for many. There's good discussions on that topic going on. And finally, those some new, really exciting product releases. So I will start with the technology side. I will a little bit extend what Jeff already mentioned, that where does this 7signal come from? We come from the mobile side originally. I used to work about 12 years with Nokia networking side. You can see there a picture of mobile network base station site. And on the right hand side there are cabinets. Those are Nokia Ultrasite, or nowadays it's NSN Ultrasite base stations. And on the over here there are some Flexi base stations. So this is a part of the history of 7signal as well. To extend a little bit this, last years when I was working with Nokia, I got really involved with the performance management aspects of mobile networks. Mobile networks use extensively key performance indicators to keep them running continuously, reliably. At the time of when the voice calls were the key thing, it was about the call success rate, drop call rate. And if you had a small drop, like from 99.2 to 99.1 in call success rate, that was a big thing for operators. And they were following these metrics even on the top management level because it was driving the business. Now in the age of data traffic, it's more about the throughput, packet loss, jitter, and latency kind of metrics. And those specific metrics are the ones that 7signal was founded to provide for wireless LAN industry to be able to take care of the service in the Wi-Fi networks. So I will talk about the way the product works. So there are three elements in our solution. There are those sensors, we call those eyes, as Jeff mentioned, and then there is another element called sonar, which is a test endpoint. It's a software running in a data center. And then there is a Carrot server, which is the engine software controlling everything what's going on there in the network. Now these eye units are placed among the access points. Eye units use beam steering. I will get back to this eye unit RF electronics later on. They use beam steering to point the energy at certain time to different direction and to extend the range of operation. Eye units run active and passive measurements. So at times it is an active client like any other actual client in the network. It connects to an access point, makes a connection to the data server, all the way to this sonar software that's in the data center. And there can be several of those sonar test endpoints as well. So you can measure different traffic paths there, like the end users as well are using. So these active measurements provide 24/7, all the time information how well the overall network is working there, including radio and the wired network. So in addition to these active measurements, we do provide passive measurements where we capture the traffic between clients and access points and calculate a lot of metrics based on that information. So we capture those packets with the beam steering and with the pretty capable device what we have there, so we get the information pretty reliably from a larger area. We typically can cover 4 to 8 access points. Obviously varies depending on the conditions, but that's the typical range where we can operate reliably, including the active measurements. Passive measurements would be possible even on a larger area. We as well, in addition to these passive measurements, we provide a spectrum analysis. We do the spectrum analysis with the beam steering, so you can see from which direction interference might be coming from. So Carat software controls these eye units, asks them to perform certain tasks, measurements, collects data back to a database, and from there on the data becomes available for alarms, reports, analytics, and so on. So let's look at the different type of measurements we make. So first of all, the synthetic measurements that I mentioned. These are the key for assessing the performance of the network all the time continuously. Then we have the passive measurements based on captures made by the eye unit with this beam steering technology there. So we can capture the frame headers, frames, layer 2, calculate a lot of matrices based on that. We obviously can see as well all the radio configurations, channels, and all those things that commonly are as well available. And then we can do the spectrum analysis. For troubleshooting purposes, if those 600 matrices that we provide continuously do not provide the sufficient information, you can make manual tests remotely. So you can ask from the user interface, eye units perform some additional measurements, even when it's running the automated cycle. So it will schedule there the next test, it will run the test and return the results right away without putting it to the database. So you can run their active and passive manual tests. As well, you can run packet captures and import those to packet analytics tools if you need to do that. Even though we have those 600 matrices, I must say that they are all obviously not needed continuously. It's a dozen or 2 dozens of matrices that are the most important. And when you get into trouble, you have that breadth of information available there readily. So these KPIs that we provide, key performance indicators, they can be categorized at different levels, and we have been using these OSI layers 1 to 7, to categorize those. And we can start from the top layer where we have the SLA and application level measurements. And those measurements provide information. Those specific metrics that I showed on the first slide, throughput, latency, packet loss, jitter, voice quality, and success rates for different transactions. Then going deeper, we provide matrices on accessibility and availability of the services there. Going deeper, we provide information on the amount of information there, basically volume, traffic volume, number of users, number of packets by different categories. We provide, for different frame types, we provide information what kind of frame volumes you have there over time. So what we essentially do, we put the time axis for all the measurements performed there. So it's a continuous sampling, and we can show all this information over time. We provide as well, for troubleshooting purposes, status codes for errors connecting to an access point. We provide reason codes status codes for accessing to the access points. These are passive measurements. Then reason codes for disassociating from the APs, and failure codes that take place when the eye is performing the end user measurement, actively connecting to the AP. And if it fails, we get to get statistics on those failure codes. Then obviously network settings, channels, QoS categories, a lot of data on the frame delivery, how well frames are delivered from end user devices to the access points and from access points to the end user devices, like retry rates, data rates over time. So we can see the varying performance there. And finally, more RF signal related metrics is like signal levels, noise levels, spectrum analysis. And we have these metrics categorized and made available in the analyzer tool that is the user interface for all the information we collect. Then a little bit about the software itself. So Carat and Sonar, they run on Linux servers. Sometimes the server may be a laptop, but when it's an enterprise installation, it is preferred to have obviously a little bit more robust platform than a laptop for the software, but it runs as well on a laptop. This software includes database. We use IBM DB2 database, which is very scalable to very large installations. Software includes a test scheduler. This scheduler defines what kind of measurements are made at certain time. And we have ready profiles for making certain type of measurements, but you can as well tailor and customize the measurements that are being made. We have alarm generators there. These processes are continuously looking at the database information there. For example, if my throughputs drop below 1 megabit per second, it will issue an alarm, which can be emailed or so on. Please.
Does the software come, is it an installer that you run on an existing server, or is it something that comes pre-packaged like with an operating system as a virtual machine like in an OVA? What's the delivery method for the engine?
Yeah, it can run on the virtual server or a dedicated server. We don't have any ready boxes, but we can do the installation for any setup. So it can be customer's hardware platform or virtual hardware platform that's being used, and we install it there.
You would expect the customer to do the maintenance on the operating system and own the OS and patch level on the operating system?
Or we can take care of that either way, or our partners can take care of that. So what we provide here is not only a platform, we as well provide services with our partners so that end customers can acquire these capabilities as a service as well. So I don't know.
It's not like a virtual appliance type of a package?
No,
okay.
it's,
all right.
It's yeah.
All right, very good.
Yes. We have automated reports coming out of product. You can define what interval, what kind of reports you want to get. These capabilities are configurable. And the overall architecture is very flexible. So if you need, you can have several of those sonars, which is the kind of, you have used iPerf and maybe iXchariot or this kind of tools, test endpoints. Sonar is the wired network test endpoint. I is the wireless network test endpoint.
Is do you support any other databases rather than the IBM one, or is that the only, that just specifically built for the application that's being run?
At this time we use IBM DB2 and only. So
Okay.
It's been optimized for this use and tweaked so that it runs pretty well there. But it's a good point. So we have capabilities to split the one platform so that certain individuals get access to certain areas only, certain data, or even so that the platform is offered. One platform serves several companies utilizing the product. So it's a multi-tenant platform. And we have automation there to clean the database, make the backups, maintain the setup.
So you're collecting layer 2 data. That data is going to be overwhelming at some point, right? So where do you store that data? Does it eventually delete and get overwritten? And then once you have that data, then you're running it through some type of algorithm to start pulling out this information. Am I understanding you right?
Yes. So what we do with those layer 2 measurements is that, and with all the measurements overall, we are not capturing everything because that would be definitely overwhelming if we would capture everything all the time. We capture the data, we calculate the metric at the eye unit, then we send the result only to the database. So this is the way to minimize the amount of data stored. So we are not saving the captures as well. And yes, the database, when you have several months or even a year or longer time data there, it gets large. So it can be automatically compacted and shortened and backed up, kind of offloaded, so that it keeps, for example, last 2-3 months of data there. Okay, so to highlight what we can do, on the other side you can see the terminals, and here you can see the servers, data center. So there is a lot of gear in between usually. So it's a complex thing, the overall network. It can be extremely complex. So we can collect information based on client device MAC address. What kind of data rates it is using, what kind of retry rates, what kind of frames overall it's using. We get information from passive measurements and as well from active measurements, how the radio link is working. Each SSID there separately banned, separately. And most of all, this is really the key. We can measure the whole network, whole data pipe. How well is it serving end users? Throughput, packet loss, jitter, voice quality, latency. These key metrics is really that matter for the end users. And we can collect this information without having any software at the client terminals because it's rather tedious to maintain that software. So we get the information, it's easy to roll out a sensor that will collect it instead of trying to install the software to end user terminals. A little bit more on the sensors. We get some questions on the sensors. I have listed a couple of those there. I'm not going to go dive in there deep. We could discuss about this, but I'd like to rather focus on the benefits that we can provide with the sensors. So with the sensors and with the Sapphire, we provide an assurance and SLA layer for the service. It's neutral, it's not vendor dependent. It works there 24/7. Those active measurements provide continuously data, how well network is doing. So we believe this is the most capable solution in the market to provide performance data of wireless LAN services.
VP, before we move on from that one, there have been some people that have been suggesting on Twitter that synthetic analysis really doesn't capture entirely what the client point of view is, and that you'll never get a real viewpoint of what the client's actually experiencing in the environment from doing these kind of synthetic tests with the eye. How would you answer that?
Very important point, and let's see if I have a slide after the next slide.
Okay.
Exactly about that topic.
Okay.
So what we really have been doing from day one, providing statistical data to take care of networks and performance in the networks. Instead of using excessively end user feedback as the main source of information, how well service is doing, we collect this automatically from the networks, and this lets us get ahead of the customer complaints. So when we proactively take actions to improve the network, the number of customer complaints will go down if those matrices that we collect are meaningful. So when the matrices improve, customer complaints go down if these matrices are meaningful. That's the key. Okay. So I think it was on the other presentation. Let me address that question of how to measure the eye unit is in the ceiling. Clients are usually on the ground, not in the ceiling. So these active measurements that we perform measure network's capability to provide good service. So it's a capability measurement, how well network is capable of performing. It doesn't mean that end users are getting that service level. So the first phase is to measure those active measurements to see what's the network performance and optimize it. Secondly, it's important to make sure that the clients are capable of utilizing that capability, and this happens through the passive measurements, capturing the packets, calculating the key metrics based on this passive data. So it's always a two-phase process, and that's an excellent question, really. I think it's in the optimization part. I have a slide on that as well. Very important point. So all great technologies have great names. We haven't had a name for the way we use the beam steering with our product. So we have named it the Airbender, and I will explain you why.
The last airbender?
The first.
The first.
Yeah. So that's the eye unit opened up. I have here one as well. Let me see if I can. So basically this goes to the ceiling like this, and then it has the beams there. So this platform runs a Linux computer in it. It runs one radio card. So not several radios, one radio. We have a switching matrix there, RF switching, that can switch any of these antennas at certain time to any of these antenna patches. Each of these antenna patches have a 7.5 dB gain, up to 20 dB front to back ratio. So we have a pretty capable device RF-wise. We have as well there low noise amplifiers and things like that that maximize the range. I have taken some pictures of some other devices there so you can see the difference in the antenna and RF parts. So any standard like USB adapters, they have very small antennas. They don't have gain. There is no gain. It may be matched so that the energy is passing, but it doesn't amplify signals from certain direction or suppress from the other direction. So what we are doing with the airbender and why it is called an airbender.
Can you pass that around?
Sorry?
Can you pass that around?
This one, okay, yes. So the eye is placed there among the access points. And when we configure the system there, we select certain direction to measure always that specific access point. So we are not switching it continuously like typical beamforming technologies would usually do.
So do you manually orient the eye? Like is there a north pointer on the eye?
Yeah, there is a compass.
There's a compass. Oh,
Yes.
so it does orientation
It knows
automatically.
how it is positioned. And you know, the beams and the compass, and you put it there on the map, and you put map north, it can,
It
know.
knows which way it's pointing.
Yeah. So
Well, there you go.
when we measure one AP like this one here, we use this antenna beam. It means that we amplify that direction, signals coming from there and signals going to that direction, and we suppress the other directions. So this is important because if we run in environments like wireless LAN with limited number of channels, this other traffic in the other directions would impact pretty rapidly on the measurements. So this way we can suppress the impact of that.
Is only one of the antennas ever alive?
Yes, one at a time. Yes, and then we can switch it fast if needed. So another way to understand what we are doing there is that we are essentially moving the measurement point closer to the AP. So if it's an omnidirectional device that measures, it's like halfway towards the AP there. Halfway, or it's not exact, but closer to the AP. And by then using the antennas, we can simulate movement in the network from one single location. So that's why airbender. So it kind of moves us closer to the AP. So just to summarize the technology part here. So we collect the user experience information through active measurements. We complement them with the passive measurements. And it's our view that this capability is lacking, and you are the best experts on this. But this information is not available. We believe that this information is really needed to maintain a reliable network service. And we think it's important to manage networks based on the matrices. And we as well believe this is really the most capable platform on this area. And the overlap with the controller capabilities is actually not big because controllers know only information from their point of view, and from access point of view, we look it outside in instead of inside out.
What would you say would be the common deployment models for this? Would you want to put initially all of the eyes throughout a site, or would you want to concentrate on specific areas of the site that may be having issues? What kind of models do you have for that?
Yes, so we don't see that in large networks you would, right away install everywhere, but you start on the critical areas and grow from there. So many of our customers start with the most critical areas to install the eyes, start optimizing networks there, maintaining them there, and then start growing to the other sites, other floors, other areas. Many hospital customers start from the ED and NICU areas because they are the most critical ones. So this is a typical scenario how it's deployed. And then there are the alternative of doing this within the own team or buying this as a service from our partner or from ourselves in some cases. But we really want to work through the partners.
So do you see this as a solution that can help do things like roaming troubleshooting and analysis, right? If you've got a bunch of sensors, I guess my question is, how are you doing continuous packet captures for all clients? And so I can pull up one client and see it was on channel 1 and then it roamed to channel 6 and here's all the packets that were in between and here's a view of that transaction. Is that where this is positioned or is this something else?
We don't capture all the packets all the time everywhere, so it is basically sampling the traffic.
Okay.
And we capture that. So you can, if you want to follow certain area specifically, you can either modify the profile so that it runs certain measurements only for that area, maybe even continuously, so that you use that one antenna, one AP, you want to just follow what's going on with that. So you can do that by configuring the test profile or by scheduling there that kind of test in between the automated routines. So that's the way to do it. And if you want to have the continuous give me all packets type of approach. So I think there are different layers or different approaches. One is to have the full packet capture, get the hundreds of megabytes of data. The other is to assign the eye to measure certain area only continuously, collect certain measurements. Then you get the continuous data all the time. You get the metrics is pre-calculated, so you don't have to, dive into the large masses of data.
Have you ever seen the 7signal overlay help one vendor's hardware better than another, or do you see like a level set improvement all across, regardless of whose access points are actually providing client data?
Well, it varies obviously a lot, but I would say that it's more about how the network is configured than the vendor itself. But there are definitely differences between the vendors, what kind of changes you can do, what kind of tweaks, optimization you can do, and how they react to certain changes. So there are differences and we can see those, but it's really difficult to say if some vendor is better than another one.
Or one reacts better to having a 7signal overlay than another.
Yeah, can't say that one is better than the other one, really.
Just curious if you saw a difference.
Yeah.
So back on your, or kind of to Sam's point, or Chris's point about the deployment model.
Yes.
And then back to the original slides where, 1 eye equals 4 to 8 days.
Yes.
It sounds like something that is meant to kind of get installed and be left there. It becomes part of the environment. It doesn't really feel like a tactical kind of troubleshooting tool set where you might put it in for a couple of weeks someplace, solve that problem, and then remove it. I mean, you really see it as something that you put in and leave there. You don't move it around.
Good.
Laptop analyzer that goes where you want it to go.
Good question.
You want it to go, right?
Wait until the end of this session. But it's a good point. But we do think that you have to know continuously how your network is doing, but there are areas where you want to do a health check. I just want to get the data for 2 days. Show me how are my trends, like daytime, nighttime, nighttime, how is it doing? So we have products that we will release later on today that will help to do that.
I have 2 questions. One's from Twitter about, is there some sort of security cage that you've worked with to protect it from theft? I mean, it's kind of obvious that you've got one. And so someone asked, do you have something for security? And when you're done with that, I have another question. So
Yeah. So we don't store any data on in the I unit itself. All it's sent to the database. As soon as the I unit calculates the metric, it's sent over. So I think the I security device is like any other device. If someone steals it, takes it home or whatever, and starts playing it, it's probably possible to get in one way or another. But there is no data stored there.
Okay, and could you go back a slide to your picture with the 7? Yeah, that one. Just another question. Couldn't I, instead of using 7 dBi antennas, go with a high gain Omni with, a 15 dB Omni or something that would give me the same distance?
Good question. And so if we have the APs here, we have the I unit here. Now if I run there 15 dBi Omni antenna to get the range, basically narrow down vertically, I'm still picking, when I'm measuring this guy here, I'm picking everything from here, here, and here. And when I'm sending something to this one, I'm sending it everywhere. So the reason we use this beam steering is that we are able to do this, and we are able to suppress these other directions when we make these measurements.
It's for directionality then.
Yeah.
So it's really not beam steering, and you're just switching antennas.
Yeah. It's not actively.
So it's not steering the beam at all. It's just saying I'm going to talk with this antenna rather than that antenna.
Yeah, exactly. For each AP that's being configured, there is one antenna that will be used for measurements for that antenna. So this way we get consistent data continuously. So
And if you're using one big Omni, you wouldn't be able to get north, south, east, west out of your clients.
yeah,
That's true. And it would probably need to be that tall anyway.
So the I is single spatial stream?
yes, it's a single stream device. Yes, we get throughputs of over 90 megabits per second with that single stream. So it's overall pretty capable device.
So I had a follow-on question to the one about the different vendors. When you're doing a troubleshooting, you said that there were differences in the vendors between what you could actually tweak on their platform. Now, I'm sure all of us know here with the various platforms we work with, there's some things that you can get through the GUI, there's some other things that may be tweaking a little bit more under the hood with the different vendors' products that we can do. Do you have a set of standard best practices for what information you've gained in general through working with the different vendors, standard things that you might be tweaking for different vendors' products?
I'll cover that in the other presentation where I will talk about the optimization.
Okay.
But the short answer is that we don't have any specific vendor-specific, list that do this, and this. But yes, there is obviously some experiences that we have collected that we think what things work well. But there is a specific, rather generic flow what we attempt to do with the optimization. And I'll talk about that after the demo.
Okay.
How do you see 802.11ac deployments? If you're measuring performance of an infrastructure, do you foresee this supporting 802.11ac from a client, from an association perspective at some point?
Absolutely, we will be introducing AC products, yes. Not yet today, but we will be introducing. Another perspective to this is that when you deploy an AC infrastructure, most of your clients are still not AC clients. So most important thing is to make sure that those clients still work or even work better once you have rolled out the new infra there. You would expect them, all the devices there perform better as well because it's more advanced technology. So,
Well, and so that's actually a good point. When you're doing these association-based tests, are you changing the way you associate? Like are you emulating an 802.11n client versus an 802.11g only client versus a B only client versus an A only client? Right? Are you when you connect to the network to actually do your tests, or is it just you connect at best effort and whatever you get's whatever you get?
It's basically the latter one. We have N-capable device there. If it's a G network, it will use G, but if it's an N network, it will use N.
Okay.
So that's the way it works. And once we have AC, and the device is AC, and the network is AC, then it will use the AC. But it's a good point. Would there be a value for differentiating that? Possibly.
Well, yeah. I mean, if you want to know if you're talking about performance measurements and all of your clients are 802.11g clients and 802.11n network, what's the value in knowing your 802.11n performance?
Yeah, we can. Then we measure the network capability with the active measurements, and then per client we can see how they are being able to use, so data rates, retry rates, for example, how they are able to use the network. So this way we get pretty good view on the performance. But it's a good point that how about limiting the iRadio to certain lower standard. Of course, sometimes it's SSID specific. What you run there. So if you run VoIP without the N, for example, and you have VoIP SSID there, so we use the plug A, 5 gigs, not N. So it measures the most recent supported standard per SSID, basically.
I think we've all run into situations where we've done like warehouse measurements that we've walked around with the client with the laptop and had really good signal throughout the warehouse, whereas the clients that are actually using it, because they're much lower powered than our laptops, are unable to get connectivity. I mean, I think that variability question in the clients, it might be worthwhile being able to take that from a power point of view into account as well.
Yeah. Yes. As of today, we can see in the passive measurements that data per client manufacturer, for example. You can choose that show me these clients. You can look at what kind of traffic is going on there with them, the AP. So that we can do today with the passive measurements, but not with the active measurements.